Hey, welcome everybody. We to our Mountain States Concrete Pipe Academy presentation for the month of March. This is Pipe Installation Fundamentals. This is actually one of my absolute favorite presentations that I give. I've given it many times, and I absolutely love this one. So we are going to jump right into it here. And for those of you that don't know who I am, my name is Jason Allen. I am the director of Mountain States Concrete Pipe Association. I'm also a University of Utah graduate in civil engineering. I've been in the engineering world for 19 years, and I started out in surveying. I worked in land development, the public sector. I was a consultant engineer, mainly doing roadway design and drainage design on municipal and DOT projects. I've started my own company, and I now do marketing for, as I mentioned, the Mountain States Concrete Pipe Association. So I get a lot of questions sometimes like, so do you work for Oldcastle? Do you work for Geneva? What is the Mountain States Concrete Pipe Association? Well, that is a fantastic question. So I'm going to briefly today explain and tell you what the Mountain States Concrete Pipe Association is so that you can understand a little bit about who we are. So let's focus on that first of all. We have 4 companies that are members of this association, 4 main companies. We have a lot of smaller associate members, but the 2 companies that manufacture pipe are Geneva Pipe and Precast and Oldcastle Infrastructure. Now, Geneva Pipe and Precast, they've got plants in the Salt Lake, Orem, and St. George areas in Utah, and Oldcastle Infrastructure has plants in Ogden, Idaho Falls, and the Boise area. And so the Mountain States Concrete Pipe Association is we cover the Utah and Idaho areas, and so I spend most of my time traveling throughout the state, the states of Utah and Idaho, talking to folks. The other 2 companies, I mentioned there were 4, the other 2 companies that sit on our board of directors and are heavily involved in the direction that we go are Ash Grove and Wholesome. These are our cement suppliers. They provide our cement to us, and they do a lot for our association. We're trying to get all of our associate members a little bit more recognition and notoriety, and help you as members of the engineering world get to know them a little bit more. And last month, as part of our Mountain States Concrete Pipe Academy, we had one of the representatives from Wholesome, Todd Laker, give a wonderful presentation about sustainability. And I'll be talking about that in a few moments on, if you missed it, how you can watch that again. So we do have some folks with us today. So I like to do some fun facts about the people that are on the call with us today, representing those different companies. First of all, we'll start with our good friend Heather Christensen. If you see this picture on your screen here, Heather is the one on the right. She's the one in the lovely dress there. So that's Heather. That's her contact information. There is her email address. Now, a fun fact about Heather: Heather was recently elected to the board of directors for the Utah chapter of APWA, and one of her responsibilities on the board is to oversee the Young Members Committee. Now, Heather, I would be remiss if I didn't give you an opportunity to give a little plug for the Young Members Committee and APWA, and it's probably, I'm a little bit older, so I don't know if I qualify. Why don't you tell the folks what qualifies for that Young Members group?
Sure. You know what? I'm really happy that you brought this up. Young Professionals Group. I'm super excited about getting this going here for the Utah chapter of APWA. There actually hasn't really been an APWA Young Professionals Group. So we're just starting to build that. So for all of you here on the webinar, if you have any young professionals, and how we define it, it doesn't necessarily have to be young. I hate how that's actually kind of just put out there right off the bat, but it's anyone who's been in the career for 5 years or less. So if maybe they started a career in a different industry and then they're moving to the public works realm, they've only been in that new position for 5 years or less, they certainly qualify. Or the age side of it is 35 years or less, or 5 years or less into their field. So I am really, really excited about it. So if you know anyone in your office, or if you know anyone, in the industry that you think would like to get more involved in that type of fashion, we are going to be doing a lot of not just social and interactive events. What we're going to try and do is get people involved to make a difference, make a change, maybe transition into leadership roles down the road. I mean, there's some people that are helping through APWA that have been serving that same role for 10 years or more, and eventually that person might retire or might move on to a different opportunity. And so we need to definitely make sure that we're doing some succession planning there. and filling those roles for when people decide to move on. And so we're really excited. Please send people my way. You have my email there, so please send them my way if you have any ideas of anyone, and I will gladly reach out to them for you.
Excellent. Well, thank you, Heather. I appreciate it. Also with us on the line from Geneva Pipe is Mr. Mike Blackham. Fun fact about Mike Blackham, he does not qualify for that young professionals group because he is older than 35. The other fun fact about Mike would be that he has a little brother that is a professional baseball player. He's a pitcher, played in the Mets organization for the last few years, and he was traded in the offseason to the Oakland A's franchise. So, Mike, if you're on, how's Matt doing pitching for the A's this year?
Yeah, thanks, Jason. He's doing awesome. He's had the second most outings of anyone on the team, so he's looking good. He's only given up 1 run in 4 or 5 games, so he's looking really good, and hopefully he'll get his shot finally.
Awesome. That is cool. Very cool. So his name is Matt Blackham. If anybody wants to follow along and see how he's doing in the spring training games, you can track him on the Oakland Athletics page there. So very cool. And last but certainly not least, from Oldcastle Infrastructure, we have Mr. Jeff Peck. This is the closest I could come to finding a picture of Jeff because he, like our good friend Ron Swanson from Parks and Rec, lives off the grid. Jeff Peck, the fun fact, he got me into guns. I didn't own any guns until I became friends with Jeff Peck, and he really got me into it. And now I have, we'll just say, double digits of guns. I ask Jeff this question all the time, and we'll see if I put him on the spot, if he'll actually answer it. Jeff, how many guns do you own?
Jason, we're going to have to talk about this offline. We never talk about how many guns we have in public.
You know what? I hate to break it to you folks, but he doesn't talk about it in private either. So it doesn't matter if we're offline or online, he won't tell me. So I just thought maybe if I put him on the spot with 100 people listening, maybe he'd feel the pressure and do it. I guess not. Okay. What we do
Wait, Jason, we forgot the fun fact about you.
Uh-oh, there's no fun facts about me.
Yeah.
Today is Jason's birthday, and if you remember how many years of experience he's got in the engineering field, then you can calculate his age based off of doubling that number. But I had to make sure everyone knew that's your fun fact of the day. Jason's pure presenting to you guys during his birthday.
My son said to me this morning, my 7-year-old son said, "Dad, I don't want to go to school because I want to stay home and hang out with you on your birthday." And I said, "I have actual work to do, son. It's just another day." Once I said to them earlier, once you've had a birthday 40 times, it's not really worth celebrating and excited. But thank you, Heather. I appreciate that. It is a pleasure for me to be here with you all today and sharing this message with you, even though it is on my birthday. I'd rather be doing than talking about concrete pipe installation on my 40th birthday. So
I do wish that all of the attendees could be turn their speakers on, because I remember during my birthday a couple months back, you found out, and we were sitting, where were we eating? We were out to lunch on like one of our Blitz visits. You had the entire restaurant singing me happy birthday.
That is true. It was pretty funny and a little bit embarrassing. So good thing I'm able to mute everybody so we don't have to sing happy birthday. So most of you know this. We provide technical assistance for reinforced concrete pipe in the precast concrete industry. We work closely with engineers, inspectors, specifiers, installers, and do trainings. We do them in person. We do webinars. We do conference presentations, different things. It's one of my favorite things to do is to share the knowledge that I've acquired over the years with my friends in the engineering industry. It's a lot of fun. Also, most people think that's all we do is just give presentations and be the center of attention, but we also review and write specifications. So if you have any specifications on any projects that you're looking at, box culvert, pipe, precast related, feel free to give us a call. We'd love to help you either write those or review those and make sure that it's covering everything that we need them to. That's our big thing, is we want to make sure that our products are being installed correctly. We also would answer any constructability or design questions you have. So throw them our way. We're happy to help you. As you all know, new this year, we do have our Mountain States Concrete Pipe Academy. If you go to mountainstates.concretepipe.org/academy, you can register for any of the upcoming webinars that we have. We've got all of them loaded up on our website for the next year. on what we're going to be doing this month. Obviously, pipe installation fundamentals. Just want to throw it out there. Next month in April, middle of April, we're going to do one on micro tunneling, and that will be given by Heather and Cody of Geneva Pipe and Precast. We're very excited there. You can get on and register on our website. And a cool feature that we've added this year to our webinar series is that you can actually log on to our website and register to watch past webinars on demand. So if you missed a live webinar, or if you didn't view one of the other ones, so we talked about the sustainability one, we're going to be referencing some things that we discussed in our January presentation about concrete pipe fundamentals today. If you missed those, feel free to go on. You can register. You can watch it at any time. So if you've got some time this Friday night with your significant other, I could think of nothing better than to watch an episode of The Falcon and Winter Soldier, and then watch a concrete pipe fundamentals webinar with them. So that would just be so much fun. We've also got our Pipette program this year, where if you attend 10 Mountain States Concrete Pipe Academy webinars this year, we will send you a sticker for every webinar that you send. So we'll send those out quarterly. So after this third one, we'll see who's attended. We'll be sending out the stickers. If you haven't received a button, we'll be sending those out to you as well. You put all the 10 stickers on your button, send us a picture of you wearing it, and you can win a prize. And one of those prizes is everyone that attends 10 webinars will receive one of these 2 shirts. You get to choose which one you want. You're also entered into drawings for gift cards, and one lucky winner will win a trip with us at Mountain States Concrete Pipe Association to go to Topgolf with us and have lunch and take a couple of swings. We also have our monthly project profiles that are new this year, that we're going to be highlighting a new project every month. And that is at mountainstates.concretepipe.org/project profiles. This month's profile comes to us from Geneva Pipe and Precast. This is the North Shore project in Saratoga Springs, Utah. This is a very cool development. And it is kind of a thematic mixed residential development that has kind of a Cape Cod kind of theme to it. The location, as you can see from this vicinity map, it's just on that northwest end there of Utah Lake and Saratoga Springs. And why we chose this and what makes this project unique is there was really high groundwater on this project. And I felt like this was a good choice this month because we're going to be talking about pipe installation. And this is a great picture that shows in that trench just off to the bottom right-hand corner of the screen. You can see how much groundwater they were getting in there. So concrete pipe and box culvert was a very good option and alternative for this project, because concrete pipe has a tendency to be able to withstand flotation much better than some of the flexible products. And so this project had over 13,000 feet of reinforced concrete pipe in it, ranging from 15 inches up to 36 inches. It also had 4,000 feet of 7x3 box culvert. So very cool project. It's still ongoing. The first couple of phases are complete. They're working on phase 3 now. But it's a very, very cool project. So with these these profiles, we're going to highlight one each month, whether reinforced concrete pipe, box culvert, or any precast application. At the end of the year, we're going to allow the engineers in the industry to vote, and we are going to vote on it as well to determine which one we think is deserving of the Project Achievement Award for the year. And if you have a project that wants to be highlighted, that you were either an engineer, a designer, installer, inspector, anything on, but it had to deal with either RCP, box culvert, or precast, please submit that to us. We would love to highlight that project. So let's jump right in on what we're going to talk about today. We're going to talk installation types. There's some different types of installation with reinforced concrete pipe. We're going to focus on the reinforced concrete pipe installation best practices and reference the specifications that we'll be talking about. And at the very end, we're going to give a little bit, just spend a few minutes on material comparison between different pipe materials. So with that, I'm going to go ahead and start by giving a poll. I just want to see who we've got with us today. So we're going to do a poll. I just want to see who we have today. So I'm going to launch that here. Go ahead and answer there. If you have it in full screen mode, you're going to want to exit out of full screen mode so that you can vote, because some browsers won't let you vote if you're in these polls if you're not in full screen mode. So it looks like about half have responded. So we'll keep going here. I'll give you about 10 more seconds. So make sure you answer this question here. All right, 5 more seconds, and I'm going to close it. So it looks like I'm going to share that with everyone. as you can see, most of the folks here are designers and a handful of inspectors as well. No installers this time. I've given this presentation to contractors, so I've done it to installers. You know, I've given this to installers. I've given it to inspectors to know what to watch for, and designers. So this one, admittedly, this time has a little bit more of the design side of it, what you need to know with designers, because I was anticipating this this answer. But it's good to know. So we appreciate that. As we get going through this, if you have any questions, feel free to type those in to the question box there. You can type in any questions, or you can just put it in the chat, and anything that you need to do. But anyways, yeah, we're really excited to have everybody here with us. So feel free to type in those questions if you have them. All right, let's keep going with our presentation here. This is one that I give in a lot of my presentations. I talk about what a pipe is. It has to perform two critical functions here. So most of you know by now that it acts as a conduit, that it has to take the water from point A to point B in a drainage pipe, and also it acts as a structure. It has to be able to withhold a load above it or around it. With concrete pipe, we refer to this as a rigid pipe. Concrete pipe, whether reinforced or non-reinforced. In our market, it's all reinforced concrete pipe. There are some markets that do non-reinforced. There are some markets that have clay pipe. Those are all considered rigid pipe. But those are a structure that is bedded with soil. All right. The pipe accounts for, depending on the class of pipe, depending on the type of backfill and bedding, it can account for between 70 and 90% of the entire system strength is in that pipe. And so we are building and designing a structure that is delivered and placed in a trench or an embankment. Okay, this is why we tend to see a very long service life with these rigid pipes, because it is acting as a structure. Okay, this is a picture that I love. This is from Mohawk, New York. This was a pipe, a concrete pipe that was installed. It was a sewer pipe. It was installed in Mohawk, New York in 1842. It was removed and upsized because it was too small. They had to upsize it, but it was removed in 1986, and they found that it was still structurally sound, was still conveying water, was still in service and working after 140, almost 145 years. We have a segment of this pipe in the American Concrete Pipe Association office in Dallas, Texas. So I've been able to see this pipe, and it's really cool to see a pipe that was in the ground for almost 150 years and was still structurally sound when they removed it. So we're going to focus on the specifications that surround reinforced concrete pipe. Okay, from our January presentation that we gave about concrete pipe fundamentals, we talked about manufacturing. That's ASTM C76. We also talked about some of the testing that we do with that. You would remember the deload test and making sure that these pipes are the class that we say they are. So we talked about testing as well. So this time we're going to focus on ASTM C1479, which the full name of this standard is the standard practice for installation of precast concrete sewer, storm drain, and culvert pipe using standard installations. So there's no doubt that we just like to call it 1479 or C1479 and just say the installation spec. This specification, if you look at our local specs that we use in this market, so the UDOT spec, the APWA spec that is very prevalent among many municipalities in Utah, the ITD spec, the ISPWC, which is the Idaho Standards for Public Works Construction. All of these specifications also reference this national ASTM spec. Now, I know Heather, myself, Jeff, Mike Blackham, we all sit on the committee that's called the ASTM C13 committee that actually writes many of these specs and votes to approve any changes or modifications to these. So we are heavily involved in reviewing and writing specifications in the concrete pipe industry, and that is why we always want to offer that. We have that experience. We always want to offer that to folks to help if they have any specs that they want us to look at. So we're going to be focusing on this 1479 spec. So a couple of different pipe install types that we're going to talk about today. All right, this is the most common one that we see in Utah. This is a trench installation. So you're going to see that a lot. Obviously, you have the pipe, the ground there. We've got to put the pipe underground. So we dig a hole, we put the pipe in the ground, we put the bedding in, we put the pipe on top of the bedding, we backfill, and then we and then we go about our business. So that's very common. It's the trench installation type. There are some distinct benefits of a trench installation that sometimes we as engineers don't really think about, but when it's pointed out, you go, oh, that makes sense. When we're backfilling a pipe, we know that load, there's going to be a load on top of that pipe. And so as we backfill and as we do it in a trench, those trench walls, that sidewall, there's going to have some level of friction that absorbs and distributes that load within the trench wall itself, as opposed to the second installation type that we're going to talk about in a moment. So a trench installation is a really good type of installation that is very helpful in distributing that load so that you don't have as much load on top of the pipe. Now, the second type of installation is a little bit more conservative. Okay, this is called an embankment trench, or an embankment installation. And when we look at the fill height charts in a moment, and the fill height charts that we talked about in great detail and length in our pipe fundamentals one from January, those are all designed for embankment for the specific reason that this is a more conservative installation type. And so we want to make sure that if we're pulling numbers off of a fill height chart, we want to make sure that we are designing those for the most conservative cases, because we don't want to design them for trench and then find out that we didn't class it correctly and it didn't work out. Okay, so embankment, basically what that is you can see here, this is a great example of this. You've got your flat ground that you're starting on, and we want to build up a road around it. And so what we would do is we would put our bedding material. You can actually see it in this picture that there's a different color of soil underneath the pipe there, and that is that bedding material that they've gone in and put that. We'll talk about bedding in a moment, but that's a bedding material that they put on the ground, and then they put the pipe on top that's received by that bedding, and then they'll do their lifts all up around the pipe. So you're building on the ground, and then you're building your lifts of the road basically around the pipe, and so that's embankment. Obviously, with the trench, I mentioned that it had that existing ground that has already had time to settle and come to equilibrium there and stabilization. That acts as a friction force to absorb some of those loads and distribute those loads. In embankment, we don't see that. That doesn't happen in embankment conditions, and so that's why it's a little bit more conservative for the embankment. If we do have a trench detail, sometimes we can do a special design. If it's close to a class and we want to know exactly how much load, we can actually run a program. We talked about it in our January presentation, but we can do a special design for trench if we want to make sure that we're getting it as accurate and as detailed as possible. So that is an option if the fill height charts aren't going to work for us. If it's too high of a class, we can always look and see what a difference it would make if we did the installation by trench. Okay, so let's go ahead and launch another poll question. I've got another poll. For those of you that attended our January presentation, this is a good review. I want to see how many of you were listening. And this is, I'm going to launch it right now. How many standard classes of RCP are there? Now remember, these are standard classes. All right, so there's either 3, 4, 5, or 6 number of standard class of pipes. Okay, this is for circular or elliptical. There are the same number of standard classes of pipe. Okay.
Hey, Jason, while people think about that, I add a quick little comment. I always like to talk about safety. When designing pipe, or if you're ever out on job sites talking about the trench installation of pipe, just always be aware and be safe. Make sure the trenches are done properly, that there's trench boxes if needed. Don't ever put yourself in harm's way of any kind.
Great point, Mike. I appreciate that. That is very, very good point. All right, I'm going to close this up here, and I'm going to share it so that we can see. Here we go. So a majority said 5 classes of pipe. That is correct. Now, again, in our pipe fundamentals presentation, when we talked about circular pipe, we talked about 5 classes, and in elliptical, I put Jeff Peck on the spot and asked him how many standard classes of elliptical pipe there are, and he said there were 5, and I said no, there were only 4. I was wrong. He sent me this back and said nope, there are actually 5, but we have a class A that is less than the class 1 pipe. So there's class 1, 2, 3, 4, and A in elliptical pipe. So I need to publicly apologize. I printed a retraction on the last page of the newsletter. So, but now I just need to publicly apologize to Jeff Peck because he got it right and I was wrong. So
That doesn't happen very often.
yeah, you're right. It doesn't happen very, but when it does, I have to humbly eat some pie there. So okay, here we go. Let's get back into our installation. So we know that there are 5 classes of standard classes of pipe in our market. You're going to see mostly class 3 through 5. Not a whole lot of class 1 and class 2, especially at the smaller diameters. In a large diameter, and if it's a real big cost savings, we may see a class 2, but for the most part, the difference in steel between a class 2 and a class 3 is so minimal in the small diameters that it doesn't make a whole lot of sense to make a class 2 pipe. So we focus on class 3 through 5. We've also done many special designs if we have a really deep bury situation or an extremely heavy loads during construction with a very shallow cover, we would look at maybe a special design to ensure that our pipe isn't getting damaged either from heavy loads from a deep bury situation or from heavy construction loads. So we can do special designs as well for anything over that 3,000 pounds. But those are the main classes that we focus on here. Now, if you go to our website, if you want to download our fill height charts, we talked about this before. These are, you can go down, just scroll down on the homepage of our website. I've got those available there to download. I have also made them available as part of this presentation. So there is a little tab that talks about handouts. I've provided both of those in PDF format, so you can download our circular RCP and our elliptical and arch RCP fill height chart. So those are available in this presentation, so feel free to download those if you'd like, or you can get them from our website. Either way will work. Okay, this is a trench detail that is right out of those fill height charts. So if you open the fill height charts, this is what it's gonna show you. And the reason I put this in here is because before we start really getting into the nuts and bolts of installation and how we install, we have to make sure that we understand the different names and the different things that I'm gonna be throwing out. So I like to do this and make sure everyone's on the same page, because I don't, if you refer to something as different than I do, I just want to make sure that you can see when I say a certain word, this is what I mean. Now, again, this is from the ASTM C1479 specification, right? So all of these terminology is all based upon that specification, but it's pulled out of those fill height charts. So this is actually two separate installation details in one. Okay, so for ease of noticing this, I'm going to draw this line here right down the middle. Okay, so if you look on the left hand side, this is a trench, and on the right hand side it's embankment. Okay, so when we do a trench detail, anything, on most of these are going to be the same, but there's a few little differences when we get going in there. Okay, so first off, we're going to look and see the spring line. This is the most important term that I want to make sure everyone understands. The spring line is basically that horizontal line that cuts a pipe in half. All right, so if a pipe, think about it this way, if a pipe was flowing at 50% full, 50% capacity in that pipe, the surface level of that water would be along what we call the spring line. So it's the horizontal line that cuts the pipe in half. All right. Additionally, underneath the material that is directly underneath the pipe in the bottom of the trench, this is called the bedding. So this is very important because good bedding is critical in installation of any pipe material. All right, so the bedding is very important. Now, this next part is what the manufacturer recommendation is and what is recommended by ASTM C1479. All right, notice it says the middle of the bedding is loosely placed uncompacted bedding except in type 4, and we'll get to the type 4 in a moment, but general rule of thumb, that middle third of our bedding. Now, what's that mean? What's middle third mean? Middle third of the pipe. So if you look there, I've boxed that area there that says the DO, or the outside diameter, divided by 3. So here's an example for us. Let's do a little review from our concrete pipe fundamentals. We have a 24-inch RCP, 24-inch pipe here, okay? 24 inches, we know that the thickness of a pipe is the internal diameter in feet divided by, or internal diameter in feet plus 1. So we say it's 24 inches would be 2 plus 1, so the wall thickness is 3 inches. Okay, so in a 24-inch pipe, we would say 24 plus 3 for one side plus 3 for the other. So it's 24 plus 6, which is 30 inches. So that middle 10 inches is what we would recommend to be loosely placed. And the reason for that is because this bedding, basically it receives and cradles this pipe. Okay, and if it were 100% compaction, you would have a point load all along that pipe. And when we place it loosely and it's allowed to compact the bedding itself with the pipe as it rests on top of it, and as it uses the weight of its structure to compact that bedding itself, it cradles that pipe and distributes that load over a larger area, which is better for the pipe. Now, when we test it, we do a 3-edge bearing, or we're trying to duplicate point loads as much as possible, again, so that we can be conservative in these pipes to make sure that these pipes aren't going to fail when they get into the ground. And so as we place it in there and we cradle it, we distribute that load along a larger surface area on the bottom of the pipe and on that barrel of the pipe. So that is the purpose that we ask that we loosely place it so that it can cradle that. We've had situations where engineers thought, oh, well, 100% compaction makes sense to me. So they would call out 100% compaction in the bedding. They said, we want a good foundation. Well, that's great. If you notice underneath the bedding, there's the area that's called the foundation. Fine, if you want 100% compaction there, that's great. But the bedding needs to receive and accept that pipe, so we want it loose. If it's 100% compaction in the bedding, you're going to have really strong point loads. And if the contractor is trying to kind of shift it and move it around in place, and as we start backfilling, if you've got that strong point load, you're going to increase the possibility that that pipe could crack. We've seen that happen. On a project, we had some cracking in a pipe all along the top and bottom because it was called out in the specs as 100% compaction. Once they changed that in the field after installing a few pieces of pipe and they noticed that problem, they said, well, let's try installing it loosely in the bedding there. They didn't crack another pipe for the whole project. So it works. You know, that's good anecdotal evidence that this works when we have that loosely placed bedding there. Okay. The next term that we're going to talk about is the haunch area. Okay, the haunch area is going to be that material between the bedding and the spring line. Okay, so that's going to be that material that we want to get under the pipe, and we want to try to get it under there and compact it as best as we can. The problem, you could probably tell from this picture, is you're not going to be able to get a compactor down into there. So we've got to, as we put that material in, we have to figure out a way to get that underneath the haunches because we don't want gaps or voids. Now, understand that, again, in the spirit of being conservative, I spoke with the American Concrete Pipe Association head technical engineer. He's vice president over engineering, and I talked to him, and he pointed out to me that when we do these designs for the fill height charts, we design these knowing that it's going to be hard to get good compaction under there. So they have a conservative measure in there to say we have anticipated there would be voids and gaps under there. So we're trying to be as conservative as possible because we don't want to see our products installed incorrectly and fail. And we put in some of these safeguards in there. But the idea is if you could take a shovel or something to kind of push that material down under those haunches, the more material we can get compacted into there, the better it's going to be and the better supported it's going to be for our pipe. That said, we do have redundancies, and because these are structures, they will be able to withhold a lot more load than other pipe materials. So that's the benefit of that for concrete pipe. So the haunch area is kind of that important, critical. The bedding and haunch, that's the important area there. Okay. Outside, when we look at embankment, they have what's called the lower side. So this is the lower side material that's outside of the haunch, and the trench width that is determined to be the pipe zone. So we would install some type of material in embankment. In the trench, we don't have to worry about that because it's already installed. But on the right-hand side there in the embankment condition, they refer to that as the lower side material. And then anything over the top of the spring line and the top of the pipe, we refer to that as overfill, right? So that's going to be your trench backfill or an embankment, what we're bringing in. And so we would refer to local specs and details on what you need to do for compaction and material in the trench itself over the top of the pipe. But the critical area for concrete pipe, for reinforced concrete pipe, is the pipe itself, the bedding, and the haunches. So anything up to spring line, that is our pipe zone. All right, our pipe zone and what we need to bring in. So if we need to bring in special fill and special material to get a good compaction for our bedding and our haunch area, we only have to do that up to spring line. If you're allowed to use native material in in your trenches, then you can put the native material back on top of the pipe after that. But the critical area would be up to spring line for reinforced concrete pipe. Okay, so we kind of hit that ad nauseum, so that's good. This is our type of installation page. When you open those fill height charts, you're going to see this. I know this is a lot of information, so let's go ahead and zoom in on section by section here. We've already talked about it down at the bottom, table 3. Those are our pipe classes. We've already discussed those. So let's focus on our soils here. This is table 2. These are the types of soils that we can use in these installations. So you're going to have category 1, category 2, or category 3 soils. Now these are all based on our USCS or AASHTO soil classification. So your category 1 is going to be your gravelly sand, your really top tier material that we want to use in these trenches. Okay, that's your category 1. Those are your A1, A3 soils. Category 2 is going to be those sandy silt materials that are more of the A2, A4, right? That's your category 2. And then silty clays or category 3 soils, your A5s, your A6s. All right, so anything less than that A6, so like the A7 or the USCS, the CH, that's kind of our clayey material. We don't want to use those for the bedding or for haunches. We have a lot of problems with those, so throw those out. So these are the types of materials we want to use in these installations. So when we look at that table 1, there are 4 types of installation. So notice that the type 1, this is kind of our best installation. For our haunch and our bedding, we want to use a category 1 material at 95% compaction. All right, and it talks about how thick the bedding needs to be, either between 3 and 6 inch, depending on how big the diameter of your material is. Okay, so you'll see anywhere from 3 to 6 inches in bedding on all of these, depending on the material you're using. So type 1, all the way down to a type 4. So if you notice a type 4, you can use, if you're using a category 1 or 2, you don't need any compaction on the haunch or the outer bedding. If you're using a category 3, just compact it to 85. So this is kind of your native material backfill that you're putting in and using. What I always say, and the way I look at this is, for a type 1, you're going to be spending a little bit more money on the material to bed the pipe and to house it there in the pipe zone. But you could, if you install it correctly, you could save some money on the class of pipe. So type 1, you're going to use a lower class of pipe but a higher material, higher quality material. For a type 4, you're gonna spend a little bit more money on your class of pipe, so you may have to go up a class, but you're gonna save some money on the material you're using. Typically, we're seeing like DOT specs are more closely aligned with like a type 1 installation. For municipal installations, you're seeing more of a type 2, and in private development and things, you're seeing a type 3, and a lot of times just out in a farmer's field or something, they're going to be using a type 4 installation. Okay, I know that's kind of a lot of technical stuff that I threw at you, so I'm going to show you some cool, fun, unique local concrete pipe installations here. All right, this is always been one of my favorites. This is the Ogden City Public Works building. If you notice, all of the columns and pillars in this building are reinforced concrete pipe stacked on top of each other. This is the outside looking in. This is on the inside. You can see these columns inside that are reinforced concrete pipe. So kind of a cool showcase of reinforced concrete pipe. This is at my friend's office at Focus Engineering. They made their front desk to have concrete pipes on there, so that's kind of cool. And that, I don't know what that middle one's doing. All the supports being held up by the outside pipes there, if you were wondering. And this is one that I just saw about a month ago. I was having lunch at the Lost Texan Barbecue in Pleasant View, and I walked by and I noticed that they had flipped a concrete pipe on its side, and they were using it as a fire pit outside. So when people want to eat outside and have a fire, they use this concrete pipe as a fire pit. So those are just some fun, kind of unique local pipe installations there that I wanted to share with you. Okay, so trench widths. This is a big question that we get asked a lot, and one that can cause a lot of problems if we don't do it correctly. We're going to use our example of a 24-inch pipe. Okay, per ASTM spec. So per ASTM C1479, the recommendation is a 40-inch trench for concrete. They recommend outside diameter plus 10, basically. And I look at that and I think, okay, so you've got a 30-inch pipe plus 10 inches. That's only 5 inches on either side of the concrete pipe. And I have to think to myself, is that enough to really get good material under the haunches to get that compaction? I don't know that I necessarily agree with that. I think that's a little bit small for a really good installation. This is a situation where maybe the national spec isn't, it may be good for certain areas, but I just don't know that I agree with that. I think a little bit wider trench would be good to try to get that compactor in there. Some compactors, usually you're looking at about 12 inches on either side that you're going to want to get good compaction. And in addition, what about if you only have 5 inches on either side? Well, sometimes our bell will stick out 2 to 3 inches as well. So now you've limited that 5 inches down to 2 or 3 inches is all. So that seems really low for me. Just for reference, for the ASTM spec for plastic calls out 47 inches. So still only about 8 or 9 inches on either side of that. So I don't know that that's enough to really get the good compaction we need for a quality installation. I always just recommend make sure that your trenches are wide enough for compaction. That's always been my recommendation to contractors and inspectors and designers and people that are writing the specs. Just make sure it's wide enough that we can get the compaction that we need. All right. So let's talk about joints. This is another fun one. This is a picture of there's 2 different types of joints. This is the first one. It's less common here in pipe. This is the tongue and groove. You notice it's a flat inline pipe. So the joint sits right in that pipe. It's recessed into the pipe itself, so you don't have the bell sticking out. This is very common in like box culverts or elliptical pipe, but we don't really use this in our markets here for reinforced concrete pipe. You will see this at larger diameter. So when you get into really large diameter concrete pipe, you might see a little bit more of that. But generally speaking, we're looking at the second type, which is bell and spigot. This is the most common that we have here. The ASTM spec for this is ASTM C990. And when we use that tongue and groove, I'm going to go back, this tongue and groove one, generally your joint, you're going to have a mastic around the outside of the spigot there as it goes in. And so you're going to use a bituminous mastic joint material there to try to seal it as best as you can. Now, the bell and spigot is beneficial because you're using rubber gaskets for those. Now, there's 3 different type of rubber gaskets that I'm going to quickly go over with you here. You've got your O-ring, you've got your profile, and you've got your self-lubricating. And I'll show you how each of those work in just a moment. The specifications are C361 and C443. Those are the national specs. These rubber gaskets are designed to be able to withstand 13 PSI, right? So you have, that's how much pressure and head you could put on these pipes. We get a lot of questions about that. What's the highest pressure you get out? Can you pressurize these? Can you use, I've got it, the water's going to back up in my detention pond and I'm going to have some head on this pipe. How much head can I have on it? So 13 PSI is what these rubber gaskets are rated for. If you need a higher pressure, let us know. We have some options that we can look at to help you. If 13 PSI is too low, let us know. There's always solutions that we can discuss and help you out with that. Don't just write us off and say, oh, well, it's over 13, we can't do that. That's what these are generally, the standard is designed to, but there are options that we can look at to help you if you have to go above that. So this first one, this is an O-ring. With all of these gaskets, as you put them on, you want to equalize these gaskets. If we were in person, I would hand everybody a rubber band and I would say, put this on your wrist. So imagine for a moment that I hand you a rubber band and I say, put it on your wrist. And everybody's gonna, I guarantee you, every single person is gonna put it on their hand and then they're gonna take one of their fingers and they're gonna run it around their wrist, okay? And the reason for that is that's basically what we do. The same thing with gaskets is equalizing that. The purpose is when you stretch that rubber over your hand, that rubber band, it's going to pull to one side. So it's going to be really tight and there's going to be less material on one side than on the other. So when you grab your finger and run it around the outside of it, it balances the amount of rubber material around that rubber band around your wrist. So it's no different in these pipes. As you put a rubber gasket on, you tend to pull it, you start at the top and you pull it down to the bottom. So it's a little bit tighter at the top and has less material up there than it does at the bottom. By equalizing that, you're moving that rubber material around the entire pipe so that it's a little bit more balanced and you don't have issues where there's more material in one spot so it can crack or break your bell there in your joint. So make sure that we're equalizing those as we put those in. So the way that this one works, it's really cool. You've got that little groove you can see in the spigot end, and we lubricate that we put a lot of lubrication on that gasket, on the spigot. We want to make sure it's really able to spin inside that groove. So as the spigot, as we're homing that pipe and we're pushing that spigot end into the bell and it makes contact, the lubrication on the bell and the spigot and the gasket itself will cause it to spin inside that groove. And once it gets to the point where it's homed in, it will flatten and tighten against the wall of the spigot and the bell and create that seal to withstand that 13 psi of pressure there. So that's how we seal with an O-ring gasket. All right, the next one is our profile gasket. This is one that we want to make sure it's installed correctly, you know, with the face of it facing towards the inside of the pipe. So with our spigot, we've got almost like an arrow pointing at the bell. We want to equalize it. We want to lubricate around. Once the profile gasket is put on the spigot end, then we would put lubrication around the spigot. But we don't really want to lubricate the spigot before we put this on. It makes it really hard. I've heard contractors say we tell the new guy to put lubrication on before he puts the gasket on, and then they watch him struggle trying to get that thing to stay on there. So they think that's a pretty funny joke there. As this pipe goes in, you can tell the profile gasket, these are the 3 pictures here that go in. As it goes, it folds over and it creates that seal within between the spigot and the bell end there. So that's how that one works. The last but certainly not least, this is actually becoming the most common joint that we use in this market. This is called the self-lubricating gasket. If you look in the figure on the top left-hand corner, there's kind of that white area with those teeth that are sticking up. That is the area where there is lubrication inside that. So we don't need to lubricate any of this on the outside. It's already lubricated in there. So that chamber houses and holds lubrication. And as you push that in, you place it on the spigot end there. And as the spigot end is homing into the bell end, it rolls, it kind of folds over on itself. I don't want to say roll, but it folds over. And those teeth in that lubrication chamber catch and lock into place and hold it into place so that you can seal it. We had someone one time take some lubrication from a job where they had a profile gasket and use it on a self-lubricating gasket, and these gaskets were sliding off, and the problem was it caused it to slide off, and as they were homing and trying to get this pipe put into place, it was slipping and sliding in, and it actually we had gaskets that were hanging inside the pipes. We had to go in and cut those off, and contractor had to cut them off and reseal with a non-shrink grout. So we don't want to see that happening. So make sure that you know what type of profile gas or what type of gasket's being used so that we can make sure we're doing it correctly. Okay. So this is a picture of what it looks like. You can see those teeth inside that lubrication chamber. This has been cut in half. Obviously, we don't give you half of a gasket when we try to install these. So this one's been cut in half, so you can see what it looks like on the inside of there. So that chamber holds the lubrication, and then it folds over on itself there. Okay. Next, this is really important here. We want to make sure that we're supporting these on the barrel. The circumferential steel in the pipe is what is there to withstand the loads on top of it. And so in order to get the benefit of that circumferential steel, we want to make sure that we're supporting it on the barrel. So we have to dig bell holes. All right, those bell holes are really quick and easy to dig. If you've placed the bedding and haven't compacted it at 100% and you've just done loosely placed in the middle there, it's pretty easy to dig a little bell hole with a shovel. Also, you want to sometimes make sure you're digging them depending on the size of the pipe and how you're putting them in. If you're using if you're lifting that pipe into place in the middle of it, you want to dig a little hole underneath so you can get the choker out. So that's always important. But what happens is if we don't dig bell holes and we put loads on it, we know that these pipes are going to act basically as beams, right? They're just going to be little beams, and we know that beams, when a load is placed on the middle of that, they want to deflect. We also know that concrete pipe does not want to deflect. So what does it do? We start seeing cracks in the middle of the pipe, just like this. So as it cracks in the middle of the pipe there, I've watched videos where the contractor says, I have no idea what happened, but we had cracks every 4 feet, we had from the joint on these 8-foot sticks of pipe, right in the middle of every pipe. Well, I could probably, tell you exactly what happened. We didn't dig bell holes, so we saw those cracks in the middle of the pipe. We don't want to see that, right? So make sure that we're calling that out, that we need to dig those bell holes. Okay, when we home the pipe, we don't want to use the bucket of the excavator. If it's a small diameter, we can use a pry bar with a piece of wood over the front of it so that we're putting that pressure against the wood and not the concrete itself. We can use, for larger diameters, we can use pipe pullers. I've talked to some people that say we like to put like a 4x4 block on it, a wood block on it, and just kind of lightly push it with the excavator. If you got a really good excavator, you know, operator, that could be a viable option, but that's, you know, you don't want to push too hard and damage the pipe itself. So this is a picture of a joint gap here on the outside of the pipe. I show this because you may look at it and say, oh wow, there's a joint gap on the outside, but it doesn't necessarily mean there's a joint gap on the inside. Okay, these joints are designed, each plant does these different, and they have recommendations. You'll see some type of table like this to show that in order to get that 13 psi, there are some allowable joint gap tolerances. So you'll just need to check with the manufacturer of what those are before and put those in your specs. So now, as we go in and start putting in the backfill now, this is a good picture that shows how wide that trench is, and they've got their shovels and they're putting that down in to get under the haunches there. I show this picture. This is from a video of an installation that we did down in Arizona, but you could see the compactor there. These widths were about 12 inches wide. So you could see that they have 12 inches in there, and they're able to get that compactor in there. So anything less than that, it makes you really think, boy, that 5 inches, there's no way you'd be able to get good compaction in there. But when you backfill, and here's another picture of them compacting up to the spring line. So you notice there, they've got that compacted up the spring line, and then they're good. So here's a couple of practices that we want to avoid, right? We want to home the pipe with the excavator bucket. That's a practice we want to avoid, unless, as I said before, if you've got a good operator and you've got that 4x4 block in front of there, that could be an option, but try to avoid that if you can. Regrading the bedding while the pipe is home. So pipe's in, we lift the pipe up and we try to regrade it to get it on bed, or regrade it to get it on grade with the bedding and pull some of that. That's going to pop your bell and your spigot and crack your joints there. Using the excavator bucket to put the pipe on grade, like smashing it down and just tapping on it and hitting it. If you're going to do that, use some timber and just push down lightly on it. Improper joint lubrication, which means you're lubricating your self-lubricating gaskets or you're not lubricating the other ones. And then lastly, inadequate trench width is also a problem that we want to try to avoid there. So this is a frequently asked question that I get from contractors. All right. They come to me and they say, can I substitute a flexible pipe, either a plastic or a corrugated metal, for reinforced concrete pipe on my project? So let's see what you all have to say. I'm going to launch this last poll question here, and I'm going to let you answer that. 4 different options here: yes, no, I don't know, or it depends. You tell me what you think. Can we substitute flexible pipe for reinforced concrete pipe on a project? Okay. So I'll give you just a couple more seconds here. Looks like most of you, about 80% of you, have voted, so we'll give you just a bit more here. And all right, I'm going to close it now and share the results here. So looks like most of you said, a couple of you were honest. One of you was honest and said, I don't know. But some said yes, some said no, and most said it depends. I would say, well, why don't I just share with you here what I would say here. Okay. The answer is, if a project is designed for concrete, flexible pipe is not an equal substitute. So you must update the design if a contractor changes to flexible pipe. So if they say, no, we're not going to use RCP, even though it was in the design, we're going to change it to flexible pipe. So I would say that the best answer to that would be, it depends, right? If you are not going to change the design, then the answer is no, it is not an equal substitute. If you are going to go back and modify and update the design for flexible pipe, whether it's corrugated metal or plastic, then yes, that would be allowed. So it depends. It depends on what the situation is and what it is. The other concern that we need to take into account as design engineers are, can I swap it out for a flexible pipe that in that North Shore project, as we mentioned earlier, that had high groundwater and issues? Probably not a good option, right? To use a lightweight flexible pipe that is a liner that could potentially float on us and give us problems when the groundwater is high. We don't want to see pipe heaving our road and causing problems down the road for the next person to have to fix. So we've got to be smart about all of these things and what it is. So it depends. I would say that's the best answer there. So lastly here, I want to give just a quick comparison between rigid and flexible products here. So, you know, I just want to show why why it's not an equal substitute, just so that we're on the same page, we understand here. So we're going to talk about the type of pipe is rigid and flexible pipe. So those are the two different types here. So for the feature of each of these, a rigid pipe is a structure, while a flexible pipe is a liner, right? So one is a structure that we manufacture in the plant, we deliver to the site, we put the structure in the trench, and we backfill around the structure. The other one is a liner that goes in to act as the conduit to transmit, to convey our water from point A to point B, and then we have to build the structure around that liner, all right? The next reason why it's not an equal substitute is the pipe zone, right? If we have a trench detail and we show the pipe zone for rigid pipe, as I mentioned earlier, it is up to spring line. We need to make sure we've got good bedding and haunch material in there and we're compacting, and it is up to spring line. For flexible pipe, that pipe zone is 12 inches above the pipe. So if we have to bring in extra material to get up to spring line on a rigid pipe, we have to bring in even more material to get up and get that good compaction to 12 inches above the pipe. Now the lift thickness, it's not specified in rigid pipe. However many lifts you need to do, or whatever the thickness is to get those compaction numbers, that's what you need to do. Now for flexible pipe, according to their standards and specifications and design handbook, it should be 4 to 6 inches of uncompacted material. So you should be putting in, you know, 5 or 6 inches of material and then compacting it. And so it is very specific on how many lifts you have to do on that. So it could be, you know, 1 or 2 lifts in concrete on a 24-inch pipe, and it could be between 7 and 9 lifts for a flexible pipe. So we want to make sure that we're calling that out, and that's why you can't just substitute it, because these have to be installed and designed differently to create the structure. Speaking of structure, as I mentioned before, rigid pipe, you have a structure that is in the plant and then transmitted and sent out into the field and put into the trench. For flexible pipe, you have to install that in the field. It has to be done in the field, the structure there. The structure design for rigid pipe, our manufacturer designs it and makes sure that it meets those structural loads. And for flexible pipe, it is the project engineer's responsibility. So if they want to substitute an RCP design for a flexible pipe, you as the project engineer have to go in and redesign it, and you're taking responsibility for that structural design and making sure that it meets the load requirements there. So I'm going to close with just this soil pipe system, just to kind of illustrate how this works. So if you notice, on the left-hand side, we've got our flexible pipe. On the right-hand side, we've got our rigid pipe. As you load on there, if the pipe is flexible, then it's going to want to deflect on the outside. So you have to make sure that you have a stiff kind of column, I guess, on the side of that pipe to make sure that it doesn't deflect outward. Okay, so you've got to really take some good time to build that strong structural column on either side of the pipe to make sure it doesn't deflect. Now on the flip side, if you have a rigid pipe and you load that, the pipe itself is the structure and is that stiff column of support, so it's not going to deflect. It's just there to withstand the loads up and down. It's not going to want to deflect on us, so you're allowed to have a little bit more flexibility on the sides. So that kind of illustrates why those two are different. So again, we talked about the installation types. We focused on the installation best practices for reinforced concrete pipe, and we did a short comparison there at the end between different pipe materials and why flexible is not an equal substitute for RCP. So I just want to thank everybody for coming in on this Thursday and enjoying, you know, and sitting in and allowing me to present this to you. I hope you enjoyed it. We do have some questions now. I noticed that some people were asking some questions. So for those of you that typed in questions, now's a good time as well. If you want to ask those questions, I'm going to stick around for a few minutes and answer them. We're at our hour mark here, but I am going to answer some of these questions here. So if you want to hear your question answered, you can stick around. If not, if you need to leave, you can always log on and view this later, and we can answer those questions. So let's see here. We have a couple of folks were wishing happy birthday, so I appreciate that. Thank you very much. It's going to be awkward when someone's watching this on demand in September and they go, oh wow, today's Jason's birthday, and they send me a text. That'll be a little weird, but oh well. Let's see here. Happy birthday, Jason. Happy 63rd birthday. Thank you, Luis. I appreciate it. That was very kind of you there. All right. Okay. Joey asked a great question. What if they need to lay it at a very precise elevation with very little slope? I'm assuming this is in response to the loosely placed bedding question. That is a great question, Joey. when we lay this, and as contractors are laying this at a precise slope, you're giving them the finished grade, right? And you're telling them where to install this at. If they're loosely placing it, they're not going to place that grade of the bedding at where it needs to be plus 3 inches, right, or whatever it is. They're going to look at the pipe at the end. So as they put it in, they're going to know how much material they need to put in to get that at that elevation there. And so while they're going to have rule of thumb, and they're going to have the you know, a way of doing it in their own best practices as the contractor, your job is to provide them with what that elevation is and what their tolerances are, and how they have to have it done. And then most contractors that I've worked with and that I've dealt with, they have specific ways that they know how much bedding they need to put in to get it at that grade. And so that's a great question. I think sometimes we as engineers go, well, they're just going to calculate to determine how much it is and how much they need to put in there. And I think a lot of contractors that have done it for a long time, they're very good at understanding and knowing how much material and how much a loosely placed material will compact and will come in as we lay that pipe on it. If they were wrong, if they were off by a little bit and they're outside of tolerances, then they would take it out and put a little bit more material in there and then set it back down in there and check it. Over time, as you do this more and more on a project, you're going to learn how much that bedding material is compacting and how much it's shifting in the final elevation and how much needs to be there. So I think it's sometimes a bit of a trial and error at first, but I think most contractors are very adept at getting that to the elevation they need it to be. So great question, though. Great question. Is it advisable to reuse gaskets if removing and reinstalling pipe, or does it require a new gasket? Rick, great question. We always recommend that you use a new gasket. If you're pulling out a pipe and it's still in good condition and you want to relay it somewhere else, this is very common in rural areas with like ditch companies or you know, water districts that are doing more irrigation, kind of open channel irrigation type stuff, and they want to reuse old pipes that are in good shape. We always recommend that you use new gaskets. We never know what condition those gaskets are going to be in, what happens during the original installation, what happens during excavation of the old pipe. But if you're going to reuse a pipe, always use new gaskets. Contact one of the manufacturers, and they can talk to you about how they can get you some new gaskets to do that. It's always better to use new, because we just don't know what condition the other ones are in. Even a visual inspection, I don't know if you're going to be able to see that it would be a really good one there. And also, Heather, Jeff, Mike, you're still on the line here. If you want to chime into any of these and correct or augment anything I'm saying, feel free to do so. Okay, here we go.
Doing great so far.
Wonderful.
Good job,
Wonderful.
Jason.
I'm passing. That's good. That's good. Okay. What changes to the design must be made in the trench design? So I think this again is relating to the question there of what would we change if they wanted to shift to a different material. Okay. So that is a great question. Luis asked that question. Here's what you want to change. Obviously, the trench design is going to change, because we talked about the pipe zone will change from spring line up to however many inches over the pipe you recommend as the design engineer after you've run your structural calculation. So the trench will have to change. You will have to run some calculations to determine if the compaction that you were having for that class of pipe, depending on the roadway loads, if that's going to be adequate. How many lifts you need to put in, that's going to want to be specified to make sure that you're getting that structural that structure built around the pipe so that you can withstand the load. So I would say that the big change is the trench detail, but in that trench detail is going to be your number of lifts, the lift thickness, the material that you can use, the compaction that you need to have that you're building that structure. So when I say, yeah, just only the trench detail needs to change, but there's so many structural calculations that go into modifying and changing that trench detail when you flip to it, when you switch to a flexible pipe, that it really can't just be like a mix and match. Like, I'm going to pull out this trench detail and put it in another one. Each project's different, and you want to go back through those structural calculations. So keep that in mind there. So when you I just lost my train of thought, but I was going to say something else on that. Oh yeah, the trench detail for reinforced concrete pipe, just to let you know, that is, we use the standard. We recommend you use that standard trench detail from ASTM-C 1479. So there's really no need to modify and change the lift thicknesses, any of that. it's all pretty much standard. So as far as the design from the project engineer, because we are guaranteeing the structural components of these pipes that they will withstand these certain loads based on the class that you specify, it's significantly less work in that structural design and putting that trench detail together. So just keep that in mind there. That's all the questions that I see there, but I do appreciate you all asking those questions. If you do have any additional questions, my contact information is on this page here, this slide that I'm showing here. So feel free to reach out, call me, email me. I'd be happy to answer any questions you have. We'd just like to close by offering all of our members that are on the line to, if they have any final words they want to say. Heather, we'll start with you. Anything you want to add?
No, I think you did a really great job on the presentation and had a lot of great information on installation of RCP. So I really don't have anything to add. Thanks,
Hey,
Jason.
thank you very much, Heather. I appreciate you being here. Appreciate you being here. We'll switch over to Jeff. Jeff, anything you want to add?
Great job, Jason, and just really appreciate all of the folks that signed up today for this information, and appreciate your interest. And if any of us can help you, please feel free to reach out and contact us. Thank you very much for your time.
Excellent. Thanks, Jeff. Appreciate it. Mike, any closing words?
I'll just close with everyone, be safe, stay healthy, and we will see you next month.
Hey, perfect. All right. Thanks, everyone. We appreciate it. This will be posted on our website this afternoon or early evening. That if you have anyone in your office, if you want to go watch it again, feel free to spread the word that they can get on and watch this on demand anytime between now and the end of the year. So we appreciate everyone. Thank you again. And thank you to our members at Geneva Pipe and Old Castle Infrastructure. We appreciate all you do for our association. If you need anything, please reach out and contact us. Have a safe one, guys.
Thank you, everyone.
Thanks. Bye-bye.